Welcome to my channel Enquest Physics students. In this class we are going to learn about the center of mass. Actually we are entering into the topic of system of particles where you will learn about the moment of inertia and others, and it is the beginning of the system of particles. We call it as the center of mass. First of all, we have to understand what is the center of mass is. Center of mass, it can be defined like this, is the point where the entire mass of the body is supposed to be concentrated. It seems like the center of gravity, but a slight difference between the two. Actually, it's the major. Generally, we define the center of gravity as it is the point in a body. Listen my words, I am stressing here. Is a point in a body where the entire weight of the body is concentrated. Okay, I am stressing the word, students. It's the point where the entire weight of the body is concentrated. Means what? Center of gravity is present in the mass of the body. But the center of mass, what I told, is the point where the entire mass of the body is supposed to be concentrated. Supposed to be means what? It may be in the body, that means what? In the mass, or out of mass. Okay, students, it may be inside the body, that means inside the mass of the body, or it is outside of the mass of the body. That's the major difference between the two. Then how these things are related? They are related. If you take the bodies have the different shapes, isn't it? Some are regular shaped and some are irregular. Generally what goes on? The center of mass of a body coincides with the center of gravity when the body is regular shaped. Means what? Regularly shaped, like a triangle, a rectangle, or a square, or a cuboid, or a cone. For all these structures, center of mass coincides with the center of gravity. Okay, students, center of mass is the point where the entire mass of the body is supposed to be concentrated. Supposed to be. It means there is no need of center of mass to be present in the mass. Okay, let's take few examples of center of mass. Okay, students, see. First we are starting with a triangular shaped plate. Okay, students, it's the plate which has a particular thickness. Okay, students. Okay. And we have to locate the center of mass and as well as the center of gravity. Center of mass is written as com, or some people like me, they write it as the same. It has both. What's that? It suits for both. Here, drop a normal from one of the vertices. Okay, and one more. And here, we join the diagonals. That means what? These lines which are drawn from the vertices, they are meeting at a particular point. Mathematically, we call it as the centroid. Okay, it's a triangular plate. It is triangular plate, students. Okay, center of mass situated at the geometrical center. Okay, it's a regular shaped body, so center of mass coincides with center of gravity. That means this position is both for center of mass and center of gravity, students. I told you center of gravity is the point where the entire weight of the body is supposed to be concentrated. Is concentrated. Okay, here the question will arise. Why would we choose the center of mass. Actually, does it exist? Actually, it doesn't exist. You can understand this thing very easily. Here, I am taking a box. Okay, it's a box. Okay, I am holding it. Means what? I am applying the force on the different positions of the body. See this? See the downwards. Here, 5 fingers of mine are balancing this body. If I remove one of that, it gets balanced. Now I am removing one. That means it is tilting. Okay. Here, if I put all the fingers together at a particular point, then I am able to hold this. This point where I am able to hold the entire body is the center of mass. Actually, inside the box, I have some weights in. That's why it is tilting. Okay, students. It is the empty. You can understand the thing very easily. See, I am holding now. Okay. If I bring all the fingers together, I can able, or I can hold in this way. It's the point where all the fingers are meeting and making the body in rest. See. Okay, and you have to remember one thing here. If you apply the force on the center of mass of the body undergoes uniform motion. Remember this sentence words. The body undergoes uniform motion when external force acts on the center of mass. That's why whenever we draw the free body diagrams, we choose the midpoint and we locate the center of mass. From there only we take the line of the force. I hope you are understanding what is meant by the center of mass. See, instead of applying the forces at all places, we are applying the force at a single point and we are making the body to move. Okay, students. Okay, it is the center of mass. Let's come to the topic again. It is the regular shaped body. I said it is the triangular lamina, where the center of mass is coinciding with the center of gravity. Let's see. We take one more body. It looks same. Okay, but it's not. Here I am taking a triangular frame, students. It is the frame. Means what? Mass is at the edges only. This is the mass. Okay. This is the hollow part. Even though it is hollow, the center of mass will be present at its geometrical center. If you watch it carefully, you will find the center of mass and center of mass is present here. It is center of mass. But I can't say the center of gravity is situated here only. It is not, because center of gravity always be present inside the mass only. There's a major difference between the two. Actually, this center of mass concept was developed to understand the motion of the body. Okay, by using the forces acting on it. It is the imaginary point. That's why I said the point where the entire mass of the body is supposed to be concentrated. Let's take one more set. This time I am taking a square plate. It is the square plate, students. Let's see where the center of mass is. Join the diagonals. These were the diagonals, and it is the plate. Okay, it is a plate. It is a square plate. Okay, students. It is center of gravity and as well as the center of mass. In the same way, if you take the same plate, it's looking like the plate, but actually it is the frame. Then see, if you draw the diagonals, then they intersect at a particular point. It is the center of mass, but center of gravity will be present anywhere in the mass only. Okay, students? In the same way, if you take a solid circular plate, okay, it's a circular plate and its geometrical center is the center of gravity and center of mass. Okay, it's a solid circular plate. In the same way, if you go with a ring, it is a ring. Here is the classic example. It's a ring. In this case, center of mass is present at the geometrical center. It's center where there is no mass is situated, but center of gravity is somewhere inside. I'm trying to define what is the center of masses. If you go with different laminas, different shapes, okay, center of gravity coincides with the center of mass for regular shaped bodies. Okay, students, here in these cases, center of mass doesn't coincides with the center of gravity. Okay, and the definition is what? There is no need of, definition is telling us there is no need of center of mass to be present in the mass only. Okay, students, and you have to remember one thing: when two bodies are taken as a system and the bodies have the same what's the different masses, the center of mass always shifts towards the heavier mass. Do remember that. And if you apply the force on the system at its center of mass, the body undergoes uniform motion. Okay, students, let's know how to find out the center of mass of two particle system. Okay, then after we'll find the coordinates of center of mass in a three-dimensional plane. Listen my words, students. Let's say it is a coordinate axis system and we are calling it as X, and obviously it is the y-axis as the origin. Okay, students, let's say a particle or a body is kept at a particular distance from the origin and it has a mass of m1, students. Okay, students, then we take one more body. Okay, students, it is another body which has a mass of m2. Okay, students, now see the location of center of mass of the body, or the distance I am taking, it is locating of the center of mass, and the distance of the center of mass of this body from the origin is x1. Okay, students, and the distance between the center to this x2, students. Okay, students, and see, now listen my words carefully. Center of mass is the point where the entire mass of the body is supposed to be concentrated, I said. That means what? There is no need of center of mass to be present inside the body. Are you following me, students? There is no need of center of mass to be present inside the body. And also you have to remember one more thing. The center of mass is always shifted towards the heavier massed body, students. If you take a system of the bodies. Here we are taking the two bodies. If one has the more mass and one got the lesser mass when compared to the first one, center of mass always shift towards the heavier mass. Here in this case, just say M1 and M2, and M1 is greater than M2. Just imagine. Its size is much bigger than the second body. Okay, students. Then obviously, the center of mass shift towards the heavier one, I said. Let's say it is axiom and its location is this. We call it as the axiom. Okay, students. See, the axiom, that is the center of mass of the body, is not at all in the mass. These two are the individual and they are behaving like a system, and it is not at all in the mass in this diagram. Maybe depending upon the size and as well as the positions, the center of mass may lie in the body or may not. Okay, students, it is the M1 and we call it as the M2, and it is the center of mass which is lying here. Here it is. Now we are locating the positions of the bodies with respect to center of mass. Let's say it is the D1. The distance of the center of mass of the system from the first body is equal to D1, and obviously it is D2. Okay, students, it's the D1 and D2, and we have to find out, okay, D1 and D2 with respect to X1 and X2, students. Before doing that, we have to learn some useful relation, useful material to find out the center of mass. What is this? Here you know about the moment, students. Moment of force and as well as the moment of couple. When we are talking about the moment of force, we said that the moment of force, it is torque, I am saying, force multiplied with the perpendicular distance. Torque acting on a body is constant. In the same way, to find the center of mass of the bodies, we have to find out moments of the mass, students. Listen my words carefully. Moments of the mass, students. Actually, the moment of mass can be written as m into d. Okay, students. Okay, m into d is equal to constant. Okay, students. The actual relation is what? Mass is inversely proportional to the location of the center of mass from the center of the mass. Okay, students. Here it can be written as m1 d1 is equal to m2 d2. Okay, students. m1 d1 is equal to m2 d2. So on is equal to constant. We need to find the d1, students. If you watch this diagram carefully, from here to here it is axiom, okay, and it is x1. If you subtract this x1 from axiom, you will get d1. That is d1 is equal to axiom minus x1. Okay, students. In the same way, we need to find d2. Here x2 minus axiom is equal to d2. d2 is equal to x2. It is the x2 and it is axiom. Okay, students. Here C means con, center of mass. I'm just putting the values in. Let's see what happens. m1 instead of d1, I'm writing it as axiom minus x1. is equal to m2 of x2 minus xcm. Okay students, it can also be written as m1 xcm minus m1 x1 is equal to m2 x2 minus m2 xcm. Okay, and it can also be written as m1 xcm plus m2 xcm, I'm bringing here, is equal to m1 x1 plus m2 x2, and we need to find the xcm, xcom or xcm or xcom. What to get? m1 x1 plus m2 x2 upon m1 plus m2. Okay students, it is the expression for the center of mass of a two body system, students. And what we got? See, I'm writing here, xcom is equal to m1 x1 plus m2 x2 by m1 plus m2 is the equation for the center of mass. Okay students, let's do one of the applications, students. Here see, I told you, okay, the product of mass and the distance remains constant. That means what? We are taking the moments of the mass. According to that, mass is inversely proportional to the position of the particle. That means from center of mass. We wrote it as the m1 d1 is equal to m2 d2 is equal to so on is equal to constant. Here we are taking a two body system, that's why we did. Then after we have to locate the distances d1 and d2 respectively, and we got it is xcm minus x1, and substituting we get, okay students, xcm is equal to m1 x1 plus m2 x2 by m1 plus m2. We are going further, students. Here now we are going to change the axis. Here already we got the relation there for the center of mass, and we are doing one of the applications of this. See the students, let's say it is the same axis system. I said it is m1 and it is m2. Here I am keeping the first body, okay students, and the second body it is, okay students. We have to locate the center of mass. Obviously it will be at higher mass. We said it is xcm. Okay, it is near to the bigger one, I said. Here we are using the same relation to find out the center of mass. You know that xcm is equal to m1 x1 plus m2 x2 by m1 plus m2. Let's say this is x2, okay students, and x1 obviously it is equal to 0 since it is kept at the origin and the center of mass is lying at the origin. Then immediately we can write xcm is equal to m1 multiplied with the 0 plus m2 into x2 by m1 plus m2. Okay students, then it can be written as m2 x2 by m1 plus m2 is the location of the center of mass. Let's say x2 is equal to L, then it can be written as, and m1 okay is equal to m, and m2 also we are taking m, and what we get, take it as m2 only, m2 L by m1 plus m2. Okay students, okay, see this, and we are taking one more example. See, we are locating the center of mass with respect to second body. I am doing the same thing, but I am changing the axis now. Okay students, it is m2 and here it is m1, the distance is L. Okay students, we have to apply the same relation. XCM is equal to m1 x1 plus m2 x2 by m1 plus m2. Okay students, that is XCM, it is at the heavier mass we said, say it is XCM, then what you get? XCM, we get the value. Here m1 x1 plus m2, it is at the origin, that is x2 is equal to 0, into 0 by m1 plus m2, that is XCM is equal to m1 L by m1 plus m2. Okay students, these are the few examples of center of mass. And now say, what is that? If the masses are same, where would be the center of mass? Okay students, here what I am saying, it is m1, say it is m, and it is m2, it is m only, and we are substituting the values. XCM is equal to mx1 plus mx2 by m1, that is m plus m. Okay students, it is m of x1 plus x2 by 2m. Okay students, then get cancelled. XCM is equal to x1 plus x2 by 2. Okay, it is the mean distance between the two bodies. In this way you can find out the center of mass of a two body system students. Then what about a number of bodies which are in the plane? Here we have the solution students. We can do it very easily. I hope you are following the class. Let's say it's a plane. Okay students, I'm taking a two-dimensional plane. Obviously it is the x-axis and it is the y, is the origin. Let's say particles are situated at various positions. Okay students, it has a mass of m1, say it got a mass of m2, and it is m3, and number of particles are distributed in this plane. We have to locate the position vector students. Let's say it is r1 bar, and it is r2 bar, and we have one more x, it is r3 bar, and so on. Okay students, in this situation, how to find out the center of mass? Okay, here center of mass R, okay, can be written as sigma m1 r1 by sigma m1. Okay students, or it can be written as R bar Cm is equal to m1 r1 bar plus m2 r2 bar plus m3 r3 bar, okay, by m1 plus m2 plus m3. Okay students, if there is n bodies, you can write plus 1. Here also we go with the same. Okay students, here if R is resolved into the components Rx I cap plus Ry j cap plus Rz k cap, in this case we can write center of mass along the x-axis. XCM, I am writing the coordinates m1 x1 plus m2 x2 plus m3 x3 plus 1 upon m1 plus m2 plus m3 plus 1. In the same way, YCM, coordinates of y-axis, is equal to m1 y1 plus m2 y2 plus m3 y3 plus so on by m1 plus m2 plus m3 plus so on, students. Similarly, ZCM is equal to m1 z1 plus m2 z2 plus m3 z3 plus so on by m1 plus m2 plus m3 plus so on, where XCM, YCM and ZCM are the coordinates of center of mass of the system, students. Okay, students, I hope you would understand what is meant by the center of mass. Again, I am defining it. It's the point where the entire mass of the body is supposed to be concentrated. It is the introduction and also that derivation for the center of mass of a two-body system or n-body system, students. If you like the video, please subscribe my channel, and not only subscribing, forward my video to your friends also, students. Thank you for watching my video.